Mhm.
Okay. I think all are easy in 4. You just know which one should be the first function and which should be the second function. This is the point only.
Yeah.
If you
Mhm.
know which function should be selected as the first function, then it becomes very easy to apply integration by parts. Now, in part A, there are two functions. One is algebraic and other is
Mhm.
cos 4x. So, which one of
Yeah.
them should be taken as first function and which should be sec?
So first function is the one where it should be easy to differentiate, right?
Yeah, yeah,
So that's the algebraic one, and then the
yeah.
integration one should be
So, what
the
is the
trigonometric.
integration by parts formula? Is
Um, so it was
first
the
function.
first function times the differential of the second, right? Or the
No, no,
integral of
no,
the
no,
second.
no. Yeah, integral of the second. First function
Yeah,
same, integral of the second function
yeah,
minus integral
of the
derivative of the
differential.
first function and integral of the second function
Yeah.
and all integration of the all of this.
Mhm,
X
mhm.
integral of cos 4x is sine 4x divided by 4 minus derivative
Mm,
of x is derivative of x is 1 and integral
yeah,
of cos 4x is sine 4x over 4.
yeah, and then the
Your mother
integral
must
of
be
that.
asking, what is this result? What are you
Yeah,
doing?
I know. I know. Yeah, she was not happy with that one. Yeah. And the worst part is they announced the result to me on like the parents' evening in front of my mom. So like I didn't know that I did so badly and I thought I like did well and everything. And then the teacher announced it while we were like sitting and talking to him, me and my mom, and it was just like
I am
it's not
just
good.
thinking that
Not good.
what is my fault?
No, 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 it wasn't anything about that. It's just like I don't even know what I did wrong. I don't even know, where I made a mistake.
So is it clear?
hmm Mm. Then it says use the answer to find out the integral
Yeah.
for the same thing, but with x squared. How do you use the answer in this situation? Do you just
X squared sine
um
4x. You just know that uh, when we apply the integration by parts on this integral, taking x squared as a first function and sine 4x as a second,
yeah.
so this will appear. X cos 4x will appear in this. Let's see how. Let's apply integration by parts. Apply parts. Let's apply parts.
Uh-huh.
First
So you
function,
just do it
first
again
function, first function same. Yeah, yeah. Tell me the formula. First function same.
times the integral of the second function,
Yes.
and then
Then
minus the
integral.
integral of the differential of the first function times the integral of the second, all integrated with respect to x.
Yes. Clear?
Yeah, I've got the formula
What is
now.
in, integral of sine 4x?
Cos minus cos 4x, yeah, over 4, of course.
Derivative
And
of
then,
x
yep,
square is 2x.
2x now.
Integral of cos sine 4x is negative cos 4x over 4.
Mhm.
Hmm. So you
What
see,
does this have to do with, like,
now you see where to apply the previous formula, previous A
yeah,
part. You see? This was your A part.
Oh, interesting. Okay.
Now put A part. Put the answer of A part here. Just put the answer of A part.
Ah, I see. So you don't have to do it again. Okay. Yeah, yeah,
Ah,
yeah. Yeah.
yes.
That makes sense. Hmm.
So shall we move ahead?
Yeah, yeah. Okay.
Yes. Should we do six?
Yeah, let's do it.
Now, actually, the problem is maybe you are leaving some questions from these exercises. That's why you are lacking some sort of experience actually dealing with some questions, some different
That
questions.
I
Every question
yeah,
is different, you know.
yeah, but that applies more to this kind of thing, where it's like all the different versions of algebra. It's like with numerical methods, there's only really like one method, right? Or like a couple methods that you have to learn. It's and not and all the questions are kind of the same, or at
Hmm.
least so I thought. But I feel like yeah, with this integration, yeah, of course you have to practice all the different because there's a million different integrals, right? But
Yeah. 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 Yeah.
for the because it's all kind of more the same.
So when is your next test?
The
When?
next test will be integration. I don't know when it is, but next test will be integration.
So practice more.
Yeah.
So the only solution is practice more. Uh,
Mm.
teachers can only do their job, tell you everything, but the more you
Um,
practice, the more will you learn. So
mm.
find this integral in part A, and this is very easy. How you will do this? Let's try this. How you will integrate this?
Um, is it not just the classic function times to the power of n plus one?
Hmm. Yeah,
Oh
yeah.
no, because I'll make power zero, right?
No, no, no. It is right.
Oh,
So
because it's a half. Yeah,
8 minus x is a half, and
yeah, yeah.
the base function, the derivative of the base function should be present here.
Which
This is
is
the
just
rule.
zero, so, or
What is
one.
the
Sorry,
derivative? No, it is not 1.
it's minus one. You're right.
Yeah, minus 1. So the rule
Hmm.
is, let me tell you again. If we have a function power n and we have to integrate this, so the derivative should be available here. Without the
Uh-huh.
derivative, we cannot apply integration. If derivative is available, then you will simply add 1 to the power and divide by n plus 1.
Hmm.
This is known as general power rule.
Yeah.
So you will use it here. The derivative is negative 1, which is absent here. So you need to make it present by
Yeah.
multiplying negative sign outside and a negative 1 inside. Now the derivative
Hmm.
is available here.
Yeah.
So just add 1 to the power so that it will become 3 over 2 and divide by a new power. And that's it.
Hmm.
That's it.
Yeah.
Right, it is negative 2 over 3, 8 minus x raised to 3 over 2 plus c.
Mm.
So this was simple. Next part is this b part. We have to prove it. X minus 2 square root of 8 minus x. Use integration by parts or otherwise. Use integration by parts or otherwise. X minus 2,
Yeah.
8 minus x. Let's do it. B part. X minus 2 square root of 8 minus x. So we have just done the integration of square root of 8 minus x. We know
Mhm.
this now.
So
So,
that's
and this is the
second function.
this yeah, this is the answer of this. So now
Hmm.
we will apply integration by parts here. So
Yeah.
first function should be whose derivative is reducing,
Hmm.
right? So this should be taken as first function because its derivative will be what? What will be the derivative of x minus 2?
Just one.
Yeah. So
Mm.
it is easy, it is reducing its degree. So this should be taken as a second function and apply integration by parts. Okay.
Hmm.
So integration by parts. First function same, integration of
Mm.
second function.
Yeah, which we've just done.
Minus integration of the derivative of the first function
Hmm.
times integration of the second function
Yeah.
and whole integration.
Mm.
So we will just put the integration we just did. This we know mm, the answer of this.
Mm.
We don't need to do it again because we know the answer of this
Yeah.
is written upward minus 2 upon 3. So the answer
Hmm.
of this is minus 2 upon 3, 8 minus x raised to power 3 over 2. What is the
Hmm.
derivative of this is you said 1 and
Yeah.
integration of this is minus 2 over 3, 8 minus x, 3 over 2 dx. We need to integrate once again here in the second term. First term is clear. Okay. And we
Yeah.
will have a plus sign here because minus into minus becomes plus. So 2 over 3
Hmm.
can be taken outside and left is to and find the integral of this. And this is easy. Again,
Yeah.
just
We're taking
apply
that.
the
Right.
apply the apply the general power rule.
Yeah.
So what is the derivative of the inner function?
-1.
So let's make it present
Yeah.
inside so that we can apply the power rule. So just apply the power rule. It will become 5 upon 2, right?
Hmm. Yeah.
And
Yeah.
add a constant here. So negative 2 upon 3 is common. Let's take some numbers and expressions common from these two terms. What is common is
-3.
negative 2 upon 3 and 8 minus x power 3 upon 2 is common.
Is it?
What will be
Oh
8
yeah,
minus
because
8?
it's just wait.
Yeah, it is in both the terms, so we can take 3 over 2 common. What will be left in the first term? Only x minus 2 will be left.
Hmm.
Yeah,
Yeah.
so left will be x minus 2 in the first term and 2 over 5 times what will be the power left? 8 minus x. Is it clear?
8 - x by the power.
Hmm?
But if the 8 - x now has power 5/2.
Yeah, 3 over 2 taken
Oh, because
outside, what will only power 1 will be left.
yeah, that's true. That's true. That's true.
Okay.
That makes sense.
Minus 2 over
I was trying
3
to divide.
times 8 minus x 3 over 2. Just add them now. Take 5 LCM. Take 5 as LCM. So this will become 5x minus 2 5s are 10 plus 5 cancelled.
Hmm.
2 8s are 16. Multiply 2 inside. 2 8s are 16
Yeah,
minus 2x.
-2 x.
So minus 2
Is
over
that
3, 8
answer?
minus x, 3 over 2. 5x minus 2x will be 3x. 16 minus 10 will be
Hmm.
6.
6.
divided
Yeah.
by 5. So what is common?
Hmm.
3 is common.
Yeah,
Uh,
it is.
what will be when we take 3 over 5? Oh, this is 3 or 2 over 3. Sorry, this is 2 over 3. Negative 2 over 3.
Mm.
If 3 is taken outside, then it will be x plus 2 left inside. So
Yeah,
the 3
yeah.
can be cancelled out from here, and we will have
Mm.
negative 2 over 5 x plus 2 times 8 minus x raised to the power 3 over 2 plus c. Let's
Mm.
see whether this is the
And that's the
answer.
final answer.
This is the right hand side or not. Minus 2 over 5 x plus 2.
Oh,
So see, this is the right hand side.
yeah. Mm.
So
I
what is
see.
next is to find the definite integral. The integrand is same. So if integrand is same,
Yeah.
just need to apply the limits in part C.
Mm.
Uh, just apply the limits. What are the limits? From 4 to 7? Yeah, from 4 to
Yeah,
7.
I think so. Mm.
From 4 to 7. So part B is this actually. So integral from 4 to 7, x minus 2 times the square root of 8 minus x is equal to this this indefinite integral, and just apply the
Mm.
limits. X plus 2 times 8 minus x power 3 over 2. Just apply the limits. Upper limit is 7 and lower limit is 4. Okay? Because we
Mhm. And you
already
always take
integrated,
the constant
yeah, this constant is taken outside.
even with limits. You can take the constant.
Hmm?
Okay.
Okay.
Yeah,
Just
that's
apply
fine.
the
That's fine.
limits. Apply the limits. Apply the upper limit. Put upper limit.
Hmm.
So we will have 7 plus 2, 8 minus 7 power 3 over 2. And when we put 4, before we have to give a negative sign. And 4 plus 2, 8 minus 4 power 3 over 2. That's it.
Hmm.
Negative 2 over 5. Just need to compute this. 9 times 1 will give us 9. Okay.
And then 6 times 8. So
Minus 6 times 4 power 3 over 2. How much is 4 power 3 over 2?
yeah,
Is 8, I think.
8. Hmm.
Right? 2
Yeah.
power
Yeah.
3. 2 power 3 is 8. So it will be 9 minus 6 times 8, 48.
48. Yeah.
9 minus 48 is negative
Oh,
39,
39.
and
Yeah, negative
negative will be
39.
cancelled,
Okay.
and 60, 78.
Hmm.
Right?
Nice. I see. I see. Yeah.
78
Nice.
over
Nice.
5.
Thanks.
78 over 5. You need to check the answer if it is correct or not. I think it is
Mhm.
78 over 5.
Yeah.
Okay. I don't know the answer. What is next?
Does 7 look interesting, or should we move on to partial fractions?
7 is same. Integration
Okay.
by parts. If you ask
Is
me,
that
I can do it. It is easy.
um? Yeah,
It is not
I
difficult.
think we've done a sec cubed one already. So let's move on to integration by partial fractions.
Sec square. What is the antiderivative of sec square?
Tan x.
10x. So here we have 3x in the argument. So the
Yes.
derivative of this 3x should be present here. If this is
Hmm.
present, you can integrate the antiderivative of sec square 3x is tan 3x.
Yeah.
But you need to make this derivative present here. So you need to divide 3 outside. So the antiderivative
Mm.
will be tan 3x over 3.
Yeah. Yeah.
Okay. If you cannot do
Mhm.
directly, you need to use the substitution method.
Mhm.
If you are, what should I say, not clear about this, then we can do it.
No, no, no. We've done enough. We've done enough.